Households, who's the demand curve? Businesses. All right, so we kind of flipped roles, and that's where we're going to start off today with looking more carefully at the demand for starters, and then we'll combine them together. So, does this make sense? Question. Here's a statement for you. A firm will hire another person. If the revenue generated by that person is at least as much as the cost of that person being hired. So copy that down. We'll try to digest it here. So for a company that's trying to maximize profits, does that make sense? They're thinking about, should I hire another person? Should I not? They're taking a lot of things into consideration. A firm should hire that person if the revenue generated by that hire is at least as much as the cost. Does that make sense for a profit maximizer?
Yes.
Yeah, right? So we're just following the idea of profit maximization at the margin. So that's why we've kind of another worker, like an extra worker. So we got our current status quo, and then we're just thinking, would it be wise to hire another person at this point? All right, so it's important to kind of hang our hat on that statement. So we got the revenue and we got the cost, so we're back to a marginal analysis, because once we dive into the details, it might not make as much sense. So I want to start off with hopefully a common sense statement that we can hang our hat on. All right, so let's think about a concept of the marginal revenue product. The MRP function, marginal revenue product. So marginal revenue product is the change in revenue, the change in total revenue from an additional unit of a resource. So I maybe should have backed up and just made crystal clear, recall, what is the profit equation in its kind of most broadest form? Total revenue minus total cost. All right, just so we got that kind of tied into this notion. And so now marginal revenue product, the formula MRP is equal to the marginal revenue times the marginal product. What was the marginal revenue formula? Marginal revenue formula. We did it earlier this week already. We've done it the last 2 or 3 weeks. Yeah.
Revenue times.
No.
No times. Total revenue.
No, that would be kind of average revenue. So just to be clear, so Tim threw out total revenue divided by quantity, right? So total revenue is price times quantity divided by quantity. Quantities cancel, you just define the price, which is kind of cool. So I'll give you an extra credit point for being wrong. Okay, so what you guys look back in your notes if you need to on what is the, you gotta have it, you should have that memorized, the marginal revenue curve. What is the marginal revenue function or not curve, I'm not looking for a graph, I'm looking for the formula. How do we calculate the marginal revenue? I'll give you a hint, I don't want to discourage Tim too much. That's kind of close. It's missing a couple symbols. Did you find it? Find it in your notes. Yeah, Daniel?
Is it change?
Good, yes. Over change in quantity. So it's missing a couple triangles. Right? So the change in total revenue from a change in quantity. So if I produce a couple more golf clubs today, what does my revenue change by? By this changing by 2 golf clubs, how much did my revenue go up by, right? So the incremental amount of revenue from a small change in production. So let's go ahead and put that in here. The change in total revenue divided by the change in the quantity of output times the marginal product. What's the formula for marginal product? That one you might have to go a little bit deeper back into your notes. Marginal product. We got all these marginal things because marginal analysis is the most important concept really in economics class. Looking at small changes. Marginal product. I got my extra credit pen out. Who's got it? Who's got it? Who can find it the quickest? Who's the most resourceful in knowing their notes? Marginal product. When we defined it, and we were kind of talking about the marginal product of labor, by the way, if that helps you find it in your notes, the marginal product of labor.
Is this way back?
It could be, yeah. When we first defined it, it was probably week 4.
Oh, so those notes back.
Oh, okay. Somebody's got to find it. I got extra credit. Just blurt it out. Don't even raise your hand. I'll give another hint. It kind of looks like that formula in a sense. Marginal product.
Change in production divided by the change in labor.
Good, by the change in labor. Good. So Valentine's on the board here. Now, did you find that way back when we did the hamburgers? Yeah, that's where we first defined it. So I think that was roughly week 4. So that was a ways back. So back when we said something along the lines of, I have 1 Russ who can make 100 hamburgers. What if I add a second Russ? How much does hamburgers go up by? A 3rd Russ, a 4th Russ, a 5th Russ, right? And what law did that lead us to that was probably one of the top principles of economics? The law of diminishing returns, or the law of diminishing marginal product. So as I add more and more Russes to the production process, and at least 1 fixed resource, which was our grill top, then the amount of product that each additional Russ makes falls. So the marginal product is the change in hamburgers from an additional Russ. Okay, so if you look at this, we kind of tells the story that we're trying to get to. So check it out. We got a change in Q here and a change in Q here. If we were simplifying this thing, what could we do? We could cancel them, right? But I'm going to kind of leave it there just to think about the change in events. The marginal product says I add another worker, and that worker makes 100 hamburgers. Those 100 hamburgers lead to $200 in the cash register. You with me? So it sounds to me like the marginal revenue product curve is the revenue generated by an additional worker. All right? So the formula kind of tells the story of what we're trying to get to by using the formulas that we had before for incremental amount of revenue generated from more hamburgers, incremental amount of hamburgers generated by another worker. Right? We combine the two together to get the amount of revenue that we're getting, marginal revenue product curve. All right, so together these things here, so revenue from more hamburgers. This is more hamburgers from more Russes. Just to kind of tie it back to our old example from 3 weeks ago or so. All right. So the other thing that we'll just kind of put as a note here that came about from that was that we have the law of diminishing returns, or the law of diminishing marginal product. So recall law of diminishing marginal product. As you add another resource, maybe we're adding a copy machine. We currently have 2 copy machines. What if I add a 3rd copy machine? How productive is my company being with a 3rd copy machine? Well, we might have really needed it. What about a 4th copy machine? Well, we still kind of needed it, but we're not using that one quite as much. What about a 5th copy machine, 6th copy machine, 7th copy machine, right? It always just works that way, that as you keep adding more and more of a resource, you're not getting as much out of that resource that you did from maybe earlier units. Law of diminishing marginal product. All right, well, let's graph this sucker. So, graphing MRP. So now we're measuring labor here. I'm going to use labor. It could be copy machines. So L is labor. And so what do you think this thing's going to look like? Maybe don't draw this right now, but A, B, or C, what do you think the marginal revenue product curve is going to look like? So as you hire more and more labor, what's happening to the revenue generated by additional people hired? A, B, or C? C? Anybody say A or B? Okay, so C is good. You got it. So C is good. Now, why do we know for sure it's C and never B or A? Law of diminishing marginal product, law of diminishing returns. So it's always going to go down. If the law of diminishing returns is true, then as I keep hiring people, they're not going to make as many hamburgers. If they don't make as many hamburgers, I don't have as many hamburgers to sell, and therefore the revenue of the product that's coming in from those additional workers has to be falling because of the law of diminishing returns. All right, so the marginal revenue product curve, the MRP curve, is downward sloping. So key point, MRP must be downward sloping due to law of diminishing marginal product, or law of diminishing returns. So now if we put a little meat on the bones, let's just go 1, 2, 3, 4. 1 worker, 2 workers, 3 workers, 4 workers. Now remember, whenever we have the M word, what magically appears here that's not written on the paper? For the 2 and the 3 and the 4, if we're using the M word, what should you be in your mind visualizing what that 2 means? If we're going up to this M word thing, whether it's marginal cost, marginal revenue product, all these marginal things, and we read off this number and let's just say it's $20. What are we visualizing? The second, good. So this is the first person, the second person, the third person, the fourth person. When you guys look on testing, homeworks, exams, in the textbook, you're not going to see that, right? So you have to kind of know that when we're using the M word, we are thinking about the incremental unit now, not just all of the units in general or something like we do with demand and average total cost, right? We're looking at the average cost of all 4 units. That number applies to all 4 units, not just the incremental unit. All right, so we've got the second worker bringing in $20 to my company. The first worker bringing in $23 to my company. The third worker bringing in $17 to my company. And the fourth worker bringing in $14 to my company. The revenue generated by those additional people is the marginal revenue product. Okay, everybody with me so far? What would be the most you'd want to pay the first worker? What could you afford to pay them? 22? 23. I didn't know if you misread it or if you maybe were thinking we need to make a little bit of money or something off of them. We don't need to make, we can break even on the people because opportunity cost always includes all of our implicit and explicit costs. So remember in econ class we can be right on the money. It's okay to earn 0 economic profit because opportunity costs are built in. So I can afford to pay $23 to the first person. How much could I pay the second person? 20. What would be my willingness to pay for the third worker? 17. How much would I be potentially the maximum willingness to pay for the fourth worker? 14. What is that starting to sound like? The willingness to pay for something. It's what? That's not what I'm looking for if I understood you right. What did you say?
Like discrimination?
Oh, discrimination? No, we're not getting into that topic here, but as far as paying different wages to different people, all I'm looking at is ultimately I'm willing to pay $23 if I have 1 worker. If I have 2 workers, I've got 20. Maximum willingness to pay 20, 17. You're right that if I did pay that to each person, I'm paying different workers different amounts. So that would be a form of discrimination. You're not wrong with that. But now what I'm looking for, what does it sound like? Your willingness to pay for things. The thing we talked about in chapter 3. What is it?
Business surplus?
Nope. Something simpler than that. You're going to kick yourself if you can't think of it. So let's see. The willingness to pay. What thing that we've been talking about all term shows your willingness to pay for things?
Elasticity?
Nope. Elasticity is related to it, but it's simpler than that. That's why you're going to be kicking yourself. Simon? The demand curve! Right? The demand curve. Think about what the demand curve, the law of demand, like the very first thing we did pretty much, or at least maybe in week 2, I guess, is when we started talking about demand. The law of demand just shows your willingness to pay. Let's write that down since the demand curve, D, that we've been writing 1,000 times in this class, the demand curve shows the willingness to pay. The willingness to pay for additional units of a good, service, and now I'm going to add resource. The way I've got it defined here. It's just showing our willingness to pay. So guess what? The marginal revenue product curve is the demand curve in the resource market. We've just recharacterized it in our profit maximization settings since the willingness to pay is now derived that way from the productivity, the combination of the productivity of the worker and the demand for the product here as it relates to how much money is going to be in the cash register when I make more hamburgers, right? So they're kind of intertwined now where we've got the demand for our product, but then we also then derive the demand for the resources used to make that product. So the demand for a resource is usually often referred to as a derived demand curve. So resource, the demand for a resource can be thought of as a derived demand. So we call it that because the demand for a resource is derived from the demand for the final product that that resource is making. Okay, let's keep that there. All right, questions or comments on that so far? All right, so now chugging right along. What is going to make this move around? So MRP shifters. Let me see what you guys come up with. We're kind of deep into this course now, approaching week 8. Here's the current setting for 1 through 4 workers. My question is, give me an example of something that would cause them to want to hire more people or pay higher pay to their labor. Yeah.
Increase in demand. Increase
in demand of what?
The product.
The product. Okay, so there has to be an increase in the demand for the final product, right? So whatever it is they're making, if it's hamburgers, then that would shift them as well. So number 1, an increase in demand for the final product. So an increase in the demand for hamburgers leads to an increase in the marginal revenue product of labor. Yeah.
Does that mean that an increase in price will also shift their market?
Yes, yeah, we're going to link that to the price here. So yes, that's the one of the pieces of the puzzle here. So the increase in demand for hamburgers, if holding all other things constant, that would mean an increase in price. So note, an increase in demand for hamburgers, let's put a little H here, for hamburgers, leads to an increase in the price of hamburgers. We can draw maybe a little mini supply-demand curve where we're measuring hamburgers now down here. Increase in demand from D1 to D2 raises the quantity of hamburgers and raises the price of hamburgers. So that's going to be bumping up the amount we're going to be able to get for hamburgers, and therefore we can afford to pay more and hire more people. All right, so that's on the demand side of things. Number two, we can have a change in product, marginal product. So an increase in productivity. So an increase in marginal product of labor. If labor becomes more productive, then each worker makes more hamburger. Which increases their revenue product. So on your graph, you might want to add, I'm going to add it here, you wouldn't have to, but you have the formula already, but just as kind of a reminder, the marginal revenue function was the marginal revenue times the marginal product. And so now, if you think about what we're doing, we're just picking off the pieces. Hey, if this goes up, that goes up. If this goes up, that goes up, right? So we're just picking off the pieces here from what we had. All right, so increase in marginal productivity. This could be through technology or a change in complementary inputs. So case A, under increasing marginal product, there could be an increase in technology. So example, our latest shock to the system that's still working through the world is ChatGPT. How has ChatGPT affected the productivity of a single worker? Can they create more documents or less documents? More in terms of the amount, spending time. If ChatGPT can handle a number of functions and putting stuff together, or that process, then that person would be more valuable to the firm. An increase in the marginal revenue product. The amount that we could pay that single person would be different. Now, what's going to happen to the number of people I need in that case? The number of people might go down, but I can afford to pay the people who remain higher. So that's kind of the big disruption going on. And then Wall Street and business executives and brokers and everybody is trying to figure out what industries is ChatGPT really helping the most, and which ones is not as big of a deal. So I went to this last conference I went to a session where some economists had done a lot of work on looking at different industries and kind of the they did it in kind of a qualitative way, but the impact of ChatGPT on different industries. And so different industries would be impacted more so than others. And so it would be a potential cost savings for some industries, which would make them potentially more profitable or being able to expand. And now they're using that as an instrument to say, these are the stock prices that are going to go up and down, right? So it's kind of an interesting thing. So just thinking about the relationship between inputs and outputs. All right, so B could be kind of similar, by the way, as an increase in capital. So more or slash better machine, which might just be the computer, the laptop, the cell phone, whatever it is, could again make that person more productive.
Could another one, not necessarily for this specifically, but could a fallen supply increase working?
So that's getting more into the dynamic of if we are going to add a supply curve here, but if there's a fall in supply, it raises the equilibrium price, but doesn't change the marginal revenue product curve, right?
Okay.
But it's an interaction between the supply and demand. And supply being the households again. So we're kind of I want to stay focused here on the business part. Like this is what the businesses are thinking. Okay.
I was thinking like a bunch of the supply gets destroyed accidentally or randomly. It's something we need more people to make up for the loss.
Yeah, so any particular story, we'd have to have kind of a natural disaster story for the whole market to be tanked, as opposed to just a single company.
Okay.
Or if it was the supply of the machines, but we're trying to look at kind of general trends for the industry. All right, let's see. So let's see. All right, so let's get into the value. So the value of the marginal product, the value of the marginal product, the VMP, is just a slight variation on this. And so I'm going to start by just kind of explaining where this really comes from. So in a competitive market, price equals marginal revenue. So remember, Farmer, Tom, Dick, and Harry were price takers, right? So if you're a price taker, then price equals marginal revenue. And therefore, the marginal revenue product curve equal to the marginal revenue times the marginal product, I'm just restating what we did earlier, is now equal to the price times the marginal product, because these two things are equal. So that's in the case of a price taker. So key point, this is for a price taker in the output market. All right, well, this type of thing helps us to see some potentially what looks like inequities and maybe in some eyes injustices in the labor market. So your book has a nice little insert here on the NBA. Who makes more money? Players in the NBA or players in the WNBA, the women's NBA? The NBA. By a little or a lot? A lot, right? So they said, now this was for Steph Curry, was the top player in 2019 at $40 million for that year. Steph Curry of the Golden Warriors. And then the top woman was Phoenix Mercury superstar Dewana Bonner. $127,000. Steph Curry, top man, 40 mil. Brianna, top woman superstar, 127,000. And so sometimes people look at that and think, well, what's wrong with the market system? There must be some gender biases, or women are, held down in society, and some of that might be true, but we have to explain a $40 million difference of discrimination to really justify that. And so you tell me, what's driving the difference between Steph Curry and Brianna? Anthony?
I feel like just like mothers don't take their daughters to WNBA games the same way fathers take their sons to NBA shows.
Okay, I don't even know if you have to be that granular, but okay, maybe that's true. I don't know. Nadia?
More people watch the NBA, so they're able to generate more.
Yeah. So from our equation, how do we explain the equation? I mean, if we look at marginal product, is it possible that Brianna, I don't know their stats, but is it possible that Brianna's more productive than Steph Curry?
Sure.
Sure. Totally possible that if we set them side by side with 3-point advantage, rebounds, all the stats side by side, it's totally possible that she has better stats than Steph Curry. I don't know if that's true or not, but I'm just trying to show a point. So what's driving this result? This one, right? The revenue generated by Steph Curry's productivity and the revenue generated by Brianna's productivity. They both work equally hard, lift weights, hit the gym, do practices, right? So their job day is probably very similar, both being professional athletes, just having a big difference according to consumers' preferences. So at the end of the day, the consumers are determining Steph Curry's pay relative to Brianna's pay, right? In a sense, in a competitive market, it's not the owners who are, making $40 million from revenues and stuff and then not sharing them with Brianna. By the way, how do I know that's not true? Let me not assume that. How do we know that that the owners aren't holding down her salary? If it was really artificially low, like 127,000 was like, oh my gosh, are you freaking crazy? What would happen in the market if it was a competitive market, which sometimes the NBA owners could be called into question a little bit, but in a competitive market, how do we know that the owner isn't oppressing, so to speak, or keeping her pay down? Let me go over here. Yeah.
Another owner would like to pay her for it.
Yeah. right? That's our whole competitive juices flowing. We need, if we have healthy competition in the market, somebody's gonna say, Brianna, I'll pay you 3 times what that jerk's paying you, right? And if she has freedom to move from one spot to the next, because we base our society on free exchange and individual property rights, if she has freedom to move, then she just goes works for the person for $300,000. And then if that's not enough, then $400,000, then $500,000, right? And then all of a sudden, and this is what happens in all of these markets, right? Because we can also look at male sports, and why aren't professional volleyball players? They're probably paid, I don't know what they're paid, I don't have any data here, but it wouldn't surprise me if it's something along the lines of what Brianna's making, 100, 200,000 or something. Do they hit the gym? Do they have weights? Do they travel? Do they practice? Do they, yeah, same old thing. But we got male volleyball players, male basketball players, both playing at a very high level, both very athletic. We probably, if we put them through a training session, they'd be equal with 40-yard dash and all that, you know, all the physical characteristics. One's getting paid $200,000, the other one's getting paid $40 million. Same thing, right? Because this is what's driving things here on the value of your marginal product is going to be a contributor to your pay. Okay, any last questions or comments, Aaron? We got to bring supply in before we wrap up. So this is the last chapter for today. So we leave the supply curve kind of, we're going to talk more actually about the supply curve in the next chapter for next week. But the supply curve shows the willingness of households or individuals to work at various wages. And so the supply curve, one of the things that the author highlights here to wrap up this chapter is how time influences supply. And we saw this before, so note, the supply curve is more elastic with greater time. So more time, this is kind of recall, more time allowed to elapse leads to a more elastic supply. This applies to demand as well, so I'll just leave it general. So I'm going to try to fire this thing up here.
Could it be that he wants to work for more money, but her contract can't be broken, or at least not broken for a price that it's worth leaving for?
Well, of course, yeah, she wants to work for more money, and yeah, if there was contracts that can lead into adjustments, and that's part of the time thing too. So with an upward sloping supply curve and a downward sloping demand, where this is really now, if we're thinking about a whole bunch of people's marginal revenue products, but the demand is the marginal revenue product curve. When people enter the labor force, it's going to bring wages down. And when the market expands, it's going to bring wages up. And so what I want to do, just so we didn't get too bogged down with, you guys can copy this graph if you want, but I like the interaction that it shows from a dynamic process.
Funnily enough, there's actually a becoming girl.
Let me talk to you after class. Raise your hands, please. All right, so on the graph to the left, we've got the product market, the housing market. So here's the housing market, maybe in a region, maybe in Kansas, maybe in some metropolitan area. And here is the wages for the resources of construction engineers. And so the kind of the play over time of how do markets kind of sort themselves out, if there's an increase in housing demand, that for whatever reason people are moving, maybe interest rates are low, a combination of both, then that causes new construction. We make new construction, we need engineers, right? And the price of the services are high. What this shows here is that in the short run, we have to use the existing engineers, right? Whoever's in the town at the time to kind of respond to this demand shock. And so the demand for engineers increases, the marginal revenue product of engineers increases because of the increase in demand, and it drives up their pay quite a bit. Like they're putting in overtime and stuff you can think of, right? Like, hey, we got a lot of work, but we'll do your job, but this is gonna be $30,000. No problem. I got lots of buyers who are wanting to get a new house. I'll do it, right? So in the short run, we have a bigger jump in the equilibrium wage to those engineers. But over time, people find out, hey, Ottawa, Kansas is booming. I think I'll move to Ottawa from Mississippi, right? And so as there's a longer period of time, the wages for engineers would tend to fall with a greater length of time involved. Okay, so that's kind of a nice little cap of the the dynamic process that's going on between the inputs and the outputs. All right, any questions? Yeah.
All the two supply curves.
This says short run and long run. It's kind of hard to see with this is the short run curve. So in the short run, we might have a bigger change in price than what we would observe in a longer period of time. All right, we'll see you on Monday. Have a good week.